Okay, hi guys, I'm back and I'm going to do week 8 task 3. So this is me explaining PowerPoint day 5 and I have it here in front of me and hopefully you guys can click along and go through it with me. So this day we're going to talk about single replacement. So last week, or whenever you watched it, I just filmed it all at once. So earlier I had taught you there were 5 types of reactions. So you've gone through synthesis, where A plus B is equal to AB. Decomposition, which is like AB breaks apart into A plus B. So those two are opposite. Right now we're going to learn single replacement. So what that is, you're going to be able to identify single replacement reaction, predict the products for those single replacement reactions. So I'm going to teach you how to do that. So what a single replacement is, an element and compound react to form a different element and compound. So this is what this looks like. Single replacement, or we just make it short and call it SR. Okay, so that you'll see me write SR, single replacement. So what it is A plus BC yields AC plus B. So if we were in class, I would be teaching you guys a little bit of this. I call it kind of like, I don't know, it's kind of like dating. And so, or swing dancing or whatever, if you want to call it that. I'm just going to grab a red pen. Okay, so what I have here is you can see the partner switch. So A was single, okay, and BC were together dancing, and then all of a sudden A popped in with C, and B got the boot. A popped in with C, now they're combined, and B's all alone. Single replacement. So you can think about that any way you want in terms of like couples or in terms of dancing. As usually I say there's square dancing in class, so we talked about that. So one guy was alone, a metal was with a compound, and the metal bumped it out. Bumped this metal was better than this metal. This guy got the boot, and a new couple was formed, and the B was all alone. He got the boot. So this is how this goes, okay? This is element plus compound yields compound, which is a new compound, plus element. A different element is alone, all right? Okay, so that was like the generalizing. Okay, this doesn't always happen. It depends on something called the activity series. So you can think of it as like in dancing or like in dating, okay? You can think of it that way too. A is only going to get to dance with C if he's better than B. If B isn't as good looking or as good of a dancer, why would you swap out? Not going to happen. If this A is a bad dancer, you're not going to dance with them. If A is a better dancer, A gets to move in, B gets the boot, okay? And when you're talking about chemicals, what that is something called the activity series, okay? So if it is more likely, it's more reactive, then it will boot out the guy that's lower reactive. If it's lower and the best, most reactive guy is already in a compound, no reaction will happen. So you can think of it like dancing, okay? So that's here in the slide. So we're going to look at an example. Okay? I'm going to show you an example here. So what we have here, it's metal replaces the metal. And that is something you're going to have to get used to. The kids mix this up a little bit. Okay? So the first type, we have the metal replacing the metal. Okay, the metal is replacing the metal. So let's look at this. If I have lithium plus zinc acetate, what is going to happen? I wonder what we can predict. Well, let's look up lithium. Lithium, right here, is Li. plus zinc acetate. We need a little scrap work down here. Zinc, when it's an ion, is a +2. Acetate is one of these on our polyatomic sheets. Acetate right here. It's C2H3O2, and the whole thing is -1. This is zinc acetate. What does it look like? Zn, open the bracket, C2H3O2, close the bracket 2. So that's what zinc acetate looks like. Zn, open the bracket, C2H3O2, close the bracket 2. What is this going to look like? Well, I'm just going to put some paper down below here so I can keep on writing. Hopefully you guys can still see this. Okay, I'm a little off center today with my camera there. Okay, so I've got lithium plus zinc acetate. So this is what this all looks like. This is perfect. So a metal is bumping out. Well, in this case, lithium is a metal. How do I know that? They're to the left of the staircase on the periodic table. If you don't know, then you'll have to look each time. Lithium's over here. Okay, zinc, you probably know in your head that that's a metal because it's kind of like a common metal. It's right here, left of the staircase. So lithium and zinc are the metals. And this acetate, it is a polyatomic, but it had the negative charge, so it's acting like the nonmetal. Okay, 2 metals and a nonmetal. So how do I know if lithium or zinc is a better dancer? How do I know that lithium's going to kick out zinc? Well, there's something called an activity series. And so it's on the PowerPoint. I'm not sure if it's listed in your textbook or not. I can have a look. But an activity series means that one is more active or more likely to react than the guy below. And lithium is higher on the activity series, and you can see that on the slide. If you're looking at the slides at the same time, you can see that. And I'm looking in your textbook right now. AC activity series. Yep, page 333. So if you turn to your textbooks on page 333, you'll see an activity series. It's a little small one, but that's okay. Lithium's at the top. I'll show you here. This is the one from your textbook. You can see this. Lithium's at the top, and zinc is about here in the middle. So you know that lithium is higher. He's the best catch of the bunch. All right? So lithium's going to bump everybody. Zinc is kind of middle of the road guy. So he might get to dance, he might not. We have to wait and see who he's up against. But today, he's up against the best dancer with his lithium. So lithium's coming in. Zinc is getting the boot. So what is my product prediction here? Well, I need to figure this out. So if lithium's coming in, I need some more scrap work here. Lithium. What's the charge on lithium? Well, I look at it. It's a +1. When this combines, this acetate, it was a -1. C2H3O2 was a -1. I do a crisscross. I get the whole thing lithium acetate written out. So this guy is going with this guy. You'll notice every time I do it, it's like starting over. The charges have to be crisscrossed on the new compound because it's not just going to be a 2. This 2 was from the zinc. Well, now he's hooking up with lithium. Lithium is a +1, so there is no 2 at the end like there was here. Okay? Each time you put together a new compound, you have to do a new crisscross. So here I've got LiC2H3O2 plus, who got the boot? Who's by himself? Zinc. So now I just double check that zinc isn't one of my super 7, and I know in my head he's not, but just for you guys, you know, you should look at my super 7 and say, is zinc alone? Nope. He's okay to be alone. Is lithium okay to be alone? He's not on the super 7. So this is our equation. And then all we have to do is balance it. Well, there's 2 acetates, so I put our 2 out. Oh, sorry. 2 acetates there. So I put our 2 on this side to give me 2 acetates. And then I got to put 2 lithium on this side now. And I got to put a 2 lithium out there. and I'm done. So that's a single replacement. Okay? That's a single replacement. And so let's look at another one. Oh. Just a sec, sorry. I have these things up on my computer so I can see what you guys see at the same time. Let's go have a look. The next example, I'm just going to start on a fresh page because that way I can start at the top. The next example is copper plus aluminum sulfate. So the first thing you should check is the activity series. So let's go back and look at the activity series. We're talking about copper and aluminum. Who's higher? Well, I see aluminum here and copper's down the bottom. So aluminum is the better catch. Aluminum is more reactive. He's going to stay in the compound. Aluminum and copper. So aluminum's higher. So remember that. So let's look at this. Copper plus aluminum. Well, aluminum is higher on the activity. He's the better dancer. He's higher on the activity. Is copper, who's not as good a dancer, going to be able to bump aluminum? No, because aluminum is a better dancer. He's higher on the reactivity. So we get to say no reaction. You stick those two together, it doesn't matter. They're staying apart. That's how it works. Okay? So you don't have to bother to do all the work. If there's no reaction, there's no reaction. That is what it is. All right? So I'm going to click to the next slide and see what you guys would have had there. Let's see here. Let's take a look at this one. Again, it's easier, I think, if I get a full sheet of paper so I can do this. And my paper's a little off today. There we go. So let's do this. Lead to carbonate plus barium yields what? What do we get? Well, first thing we're checking is this activity chart. And ours is just not as good as the one in the textbook just isn't as good as on the slide, you can see. But on the slide, barium is much higher than lead. Barium's not listed on that little one in the textbook, but that's okay. You could look up any activity series, and it would show you that barium is higher than lead. So barium is higher than lead. We'll circle the metals. Lead and barium are the metals. Barium is going to kick out lead. It's a better dancer. He's getting in there and going to be able to dance. Okay? So what am I going to get then? I'm going to get barium carbonate with lead alone. So we can write that down. Barium carbonate plus lead. Okay? So let's see what this looks like with the letters. Lead 2 carbonate. So let's do some scrap down here. Lead 2, well, lead is Pb, you can look that up, plus 2. It told us it was lead 2, that's on the periodic table. Carbonate, you guys have to use your polyatomic sheet. You'll see carbonate right here at the top. Am I pointing? Can you guys see it right here? Carbonate, CO3 minus 2. CO3 minus 2. So when we crisscross lead carbonate, we got Pb2, open the bracket, CO3, close the bracket 2. Which really reduces down, because there's 2 of each of them, to PbCO3. You can leave the bracket on. It's not perfect when you go on to grade 12 chem. You don't need the brackets, okay? But this is what lead 2 carbonate looks like. PbCO3 plus barium. Just look him up on the periodic table. There's no charges or anything because he's just an element just sitting there. Barium yields barium carbonate. Well, let's look up what barium's charge is. You'll see him right here. He's a plus 2. Come up in the periodic table. We'll put him down here on the scrap work. Barium, we know the carbonate is a CO3 minus 2. What does barium carbonate look like? Ba2 CO3 bracket 2. And when we reduce that down, because there was 2 of each, we get BaCO3. So we have BaCO3 plus lead. We don't need to say which lead, okay? Because it's just lead now. It's not lead 2, lead 4, it's just lead. PB, done. And now we gotta balance it. And look, it's already balanced. 1 lead on each side, 1 CO3 on each side, 1 barium on each side, done. Boom, done. Okay, so that was the other part. That's just another example of a single replacement. I'm just on to the slides here, trying to see. This can happen as well. So let's watch this. Sometimes it's not the metal that's replaced, okay? Sometimes, so this is example number 4, a non-metal in a compound is replaced by a more active non-metal. Okay, this is this whole slide. So all along I've been saying this metal bumps this metal. This metal is a better dancer, bumps this metal. Sometimes it's the non-metal. So let's watch what this one looks like. So I've got fluorine plus magnesium iodide yields what? Well, here we've got the non-metals. So let's circle those guys in pencil, because red pen we used for the metals. So the non-metals, how do I know what's a metal and a non-metal again? They're on the left side, they're non-metal. So I see fluorine right here, he's a non-metal. And I see iodide right here, he's a non-metal. And our metal way over here, magnesium. Okay, so the non-metals are going to switch this time. We have the same thing. We have an activity series, and I don't think the non-metal activity series is actually in your textbook, but there's a small one here on the slide. Fluorine is the most active, so iodide is definitely getting the boot. Fluorine is definitely coming in. Iodine is getting the boot. So let's write this out. We know we're going to have magnesium fluoride because it's the magnesium that stays put. It's almost like the girls are staying put this time and the boys are coming in, however you thought about the dance. Okay, so I'm getting magnesium fluorides coming in, plus who got the boot? Iodine. And you'll notice when they're not in with something, the IDE drops off and they go back to being just iodine. Because when they're just an element, there's no charge to them, so their name goes back to normal, like the front of the periodic table, iodine. So this is what this looks like. So let's do it out. So fluorine, look him up, he's just an F. Is he one of my super 7? We have to check that. Look, he is. He's special. So he's an F2 because he's one of my super 7. So fluorine plus magnesium iodide. Let's see what that looks like. Here's some scrap work. Magnesium, look him up. He's a +2. I can get this out. I can show you. +2. Iodine, right here, he's a -1. Crisscross, I get MgI2. That's what magnesium iodide look like. So when we go over here, we get magnesium fluoride. Well, we knew Mg was a +2. Let's look up fluoride now. He's a -1. F -1. Can you guys see this? So I crisscross, I get MgF2. So that's magnesium fluoride. Plus, I get iodine. We better look. Is he a super 7? Yep, he is. So he's special. He gets a 2. Now we got to balance it. It's actually balanced. Have a look. 2 Fs, 1 Mg, 2 Is. Done. We are done. We've written it out. We predicted the products. We wrote it out. And we balanced it. Okay? So sometimes it's the non-metal that flips out. Okay? It's more often the metal, but sometimes it's the non-metal. Okay, so that was the end of these PowerPoints for this day 4, whatever it is. So I'll help you a bit with the worksheet next video. Okay, bye-bye.